Yeah, awesome. We're good to go.
Hi, everybody. My name's Kevin. I work for Xcellent Technology Solutions. We are federal contractors with the United States Geological Survey. And my specific industry is GIS. I am going to start this talk assuming none of you guys have any idea what it is. So here, we're going to start off doing GIS basics. I'm going to explain what a web feature service is. And the USGS application that I was working on that kind of gave me the inspiration for this talk. Now, the code I've written for this talk is implementing web feature servers in Go, but writing your own, why would you want to do that? The short answer is you shouldn't, but there are some areas here, for example, with GeoServer, Map Server. These are existing web feature service implementations that if you encounter these problems, you may have a reasonable reason to write your own service. Oh yeah, there's going to be a code demo at the end and stuff. Yeah. Okay, so basic GIS concepts. Data is organized in layers, right? So you have vector data, which is points, lines. You have raster data, which is essentially just images that is on the screen. So all of your pictures, they're technically counts as rasters. And the application that I was working on specifically is hydrography. This is a map of the National Hydrography Dataset. It's a dataset that is provided by USGS, and it essentially shows where water is supposed to flow, because generally water is going to flow downhill. And I've had somebody say, that's actually not quite true. Sometimes water will flow uphill, because it's going to flow down energy gradients. So you can imagine a situation where if the water is flowing all the way downhill, it's going to overshoot and then fall back down. Okay, so this is a screenshot of the web application I was working on. And you know that this is in the middle of development because we got a little JSON parser error up here. And we got a little test point that I circled. Okay, and these are examples of vector points that's being rendered on a map. And mathematically is represented as a tuple of x, y, coordinates. Okay, vector line, an array of x, y coordinates. And projections. The Earth, as we hopefully all know, is not flat. But there are multiple ways of projecting a spherical thing onto a 2D surface, and it's usually represented in the metadata that you can inspect. When you grab a web feature service, it is going to come with a projection information that's telling you how to actually display it on a 2D surface. And depending on the format that you're going to get it from, so the previous one was the open source web feature service, which is it's unfortunately, it's one of the situations where the open source version is the less reasonable version because it's an XML. But this is the Esri, which is enterprise, that actually is a JSON, which is nice. And you can do stuff like reprojections. And the reprojection operation is super simple. There is a lot of math involved, but that's always abstracted away. Like you can just say, okay, this is my target reprojection. Oh, this is my source projection. This is my target projection, and then you have one function call to do that. And really, GIS is super simple. It's kind of old. It's not like anything bleeding edge. It is just you have SQL, and then you have a geometry column, which is represented here. And so the idea of a feature service or service layer is that each individual layer represents one table in the SQL as a SQL table. All right, so what is a web feature service? Well, it's just a CRUD API for geospatial vector data. And the one I'm talking about specifically is defined by the Open Geospatial Consortium. And there's like two subsets of it. There's like WFS and then WFST, which is all your writing operations. There's also something called a map, web map service, and this handles the other data set, which is your raster data. It's not focused on that, but it's going to come up briefly again later. All right, so the reason why I kind of wanted to do this talk was because when I was working on USGS, on the last team, the hydrography team, was we had to migrate our enterprise application, our application built on enterprise Esri software to open source. And so a lot of what I know, a lot of what I found out, a lot of what I learned came from this process of designing and executing that entire migration process. And the application that I mentioned before is called Hydrography Addressing Tool. And one of the use cases you can imagine is that, say you have a database of all the bridges in the country, but you want to say, I want to find all of the bridges that kind of goes over a river. Now, the metadata that goes with that bridge may not include whether or not it's just a bridge that goes over a road or a bridge that goes over a river, right? And so what this application does is you take the national hydrography data set, which it's just exported all over with vectors. A user can provide, say, a point, and just from inaccuracies, a few decimal points off, it may not lie exactly on it. And then you can say, well, maybe if this point lies within some 50 meters of a line, what we're going to do is we can draw a circle around it. This is a polygon. And then we're going to find all the lines that kind of intersects within this circle, find the closest points, and then snap to it. And of course, if a point's all the way out here, doesn't intersect with any lines, then it is not a bridge that goes over a river or some waterway. So you need to have a read-write feature to do some quality control on this, because after you do the snapping, you may want to re-update it back into the database. Another thing that's useful when you can spatially correlate just a point XY coordinate with something like NHD will be the fact that you get stream flow directions. So you can say, if you have a set of points and you want to say which point is lying upstream or downstream relative to these other points, the NHD will give you that data.
What happened to South Carolina?
I don't know where South Carolina is.
Bottom right
I think
of the
somewhere
map.
on the coast.
It's totally colored in the bottom.
This. It was just it was just one of the data sets that we were using when we were testing this. Okay. And so we talked about the spatial correlation between taking a point and then putting it somewhere on the NHD, and then you're linking the metadata all together, right? So here we go. And the workflow for this for a user is that they would have local data. They upload it to ArcGIS Online, which is it's a cloud service where it will just store all of your geospatial data. It creates a table for you. You grab the URL, send it to our application, and then we send it back to to our algorithm over there that does the QC, snapping it back, and it publishes it back to ArcGIS Online. Once they have the fully feature-corrected data set, they can download the layer back to locally. The problem is that ArcGIS Online is stupidly slow, because if you want to be fast, you have to give them more money. And so this graph right here may be a little bit, it's it is 1.2 versus 127 points per second, which is how fast you can update the feature service back in ArcGIS. This is kind of artificially deflated because we are adding a rate limiter to it, so make sure we're not getting errors with HUL.
Wait, is that right? Is that write speeds or read speeds?
It's a write speed.
Okay.
So the reason why we wanted to move away from ArcGIS Online is because GeoServer is open source. We will manage it ourselves, and so then we don't have to rate limit our users. And so what is GeoServer? Well, GeoServer is like the de facto implementation of the Open Geospatial Consortium WFS protocol. And it pretty much implements the entire web standard. And so what happens is you can have a PostGIS, which is a Postgres database with a GIS extension. You can have shapefiles, which are just files on disk. And then it will export it into a singular, into a uniform protocol, which is a web feature service. Of course, GeoServer also does all the other stuff too within the standard. And it's 20 plus years old. Right now we are version 2. Version 3 is going to be released pretty soon. And so the question is, with something like GeoServer that's out, why should you write your own? Well, you honestly really shouldn't, because if a tool exists and you're not using that tool, there's probably a gap in your knowledge that you should address. And it reminds me of a quote by Isaac Newton that I really like, is that if I have seen further, it is by standing on the shoulders of giants. Now, in situations where the giant may have a bruised ankle, you may want to consider where you're standing. And so part of what this talk is about is what are the situations where you actually would want to write your own server for geospatial data? So the reason why I went through some of the investigation was GeoServer had a security vulnerability that almost completely killed the project. But luckily, there was enough political will at the USGS to move a GeoServer forward. And the specific security vulnerability was a possible DDoS attack surface where you can overshoot the max parameters in the query string, and so you can just flood it with really, really long strings within the query parameters. This was resolved because IT built us a version of GeoServer, a Docker image with a newer version of Apache Tomcat. But that doesn't address the fact that a GeoServer is actually just a really hard tool to use, and it is so hard that the people who wrote GeoServer and actively maintain it was like, you know what? Let's write a Django application on top to just make GeoServer usable for most people. So they wrote this thing called GeoNode, and it uses a lot of the Django features, like being an identity provider, and it lets you upload. And I mentioned before that what you can do is you can connect GeoServer to something like a shapefile or GeoPackage, and it will all export it into a web feature service. But what GeoNode does instead is it says, I'm just going to convert all those things and feed it into a PostGIS database directly, and ignore the other conversion services that GeoServer provides. It communicates with GeoServer through basic auth on the back, so you have to send in a username and password with it, but that's okay because it's never really exposed to the public. And I think I memorized all my talking points, and I'm not entirely sure. I literally just said all of the stuff that I was going to say on this slide. But yes, it handles all the layer creation for you. One of the things about web feature service that doesn't specify is how you actually create your layers. And so there's just a REST API that does that. And so GeoNode comes with a lot of all these extra features that maybe you don't really want. You don't need an identity provider, and you just want to slap in a JWT or something, use another service like Auth0 to be your identity provider. GeoServer is a very beefy application. It's 4 gigabytes of RAM at the minimum, and you can't horizontally scale it. You can only just add more resources to it. And also, maybe you just don't need a web map service. If you only need to deal with vector data, GeoServer is maybe a bit of overkill for your application. So the other, on the exact opposite end of the spectrum is a tool like TinyOWS. It is written in C. It is really, really small. It is really, really simple. But the problem is, well, now you have the opposite end of the problem, which is that you have no user authentication. All of your your layer metadata is stored in an XML file. So if you have multiple users who want to concurrently write a file, you can imagine the kind of chaos that would go with that. And during my research, I don't exactly remember if you had to restart the server in order to pull in all the layer metadata. And also, I found out that there is also a Go web feature service already, but it implements the WFS3 protocol, which is a reasonable RESTful API, unlike WFS2. But WFS3 just doesn't define a post-update, the read-write operations that you would need. Also, I checked the source code for the WFS3. There was only GET requests. There was no posts. So if you want to write your own server, why would you do it? You need something super simple that supports read-write. You don't want the bloat of GeoServer. And you want to store a table metadata inside of a database instead of storing a file on a disk. And say you want to have super simple authorization logic and write in a modern programming language. All right, so then let's do it in Go. So one of the things that's nice about implementing against a standard is that it's like, we have all heard of the idea of a dependency inversion. Well, implementing against a standard supports dependency inversion. QGIS, which is an open source mapping software, supports the WFS protocol, which means in a few lines of code, like 1,000 lines of code, I can write a server that is able to take advantage of the fact that QGIS has built-in editing for you. You don't have to implement your own editing software inside a web browser, which is also nice because the majority of GIS users are going to be using desktop-based apps. I am going to start by adding a layer. Go to layer. I am going to add layer. It says WFS, OGC protocol. Grab that access token over here. Okay, so here it pulls up all the layers that is available for you for this specific user. And the request that it sent over looks like this. The important part to note is that the thing that it looks for is this get capabilities here. When you want to do a get capabilities, it's going to ask the server what kind of features the server supports, and get capabilities will return an XML that looks like this. You get here are the 3 read operations that you're going to get, like get capabilities, describe feature type, and get feature. And transaction specifies as a read-write layer. And here's the information on feature services available. And the default CRS here is the coordinate projection system. I only implemented one. So I'm going to create another. I'm going to add another layer. WFS, new. This time I don't have to specify the access token, so it doesn't contain the claim because that's already in the API headers. Next. There we go. Close. And so this part of the demo is to show the insertion capabilities. I only implement an insertion, only a certain amount of hours in the day. Layer. zoom in over here. Okay, I already added a few points, but okay, like, pretend some of these aren't there. So click that. Test data. Hello. Cannot commit changes. Oh. Did I get a
Syntax error at S. It doesn't like your apostrophe with my guess. Yeah, you can see it.
Did I have an apostrophe?
Here's some.
Oh. Okay.
So it's SQL injection.
So I'm pretty sure I added a function that is supposed to validate the SQL, but because I didn't want to do the logic that I just returned the string as is. It was just like a to do later. This is what example of an insertion transaction would look like. You can also add in like update requests. So within a single WFST transaction, you can have updates, deletions, and the idea here is you send one transaction and does all those things that you need to do. If you work with Gorm, you know that if you want to define a database model, you can create a struct. Where is that? Something like this, right? Where you tell that this ID is a primary key, and then when you do the auto migrate function, it's going to create a table for you. But one of the annoying part about this is the fact that the user can define your table schema, which means you can't rely on Gorm to do it for you. I see that confused look on your face. But if you think about it, it's like it's all of vector data in GIS is really just metadata, and you're going to want to be able to define your own columns. And somewhere in this code is to get the layer schema, does a SQL script in order to get all the column names. And if you see in the code base where I have this db layer underscore get all features, I decided to namespace all of my functions just doing the old-fashioned C style of you name your function, use an underscore as your namespace separator. So everything is within package main. Don't at me for that.
I'm trying.
I already decided to not sanitize my SQL input, so I think using package main for everything is an acceptable thing. SQL string, yes.
Yeah, there it goes.
And remember when I mentioned how tiny OWS just like has everything in an XML document? Well, you can do the same thing. You can just have your little ID here, and then you have your table name. And this table name is literally just the name of whatever SQL table here with your GIS data. And so if you create a new table, you create a new entry here, you create a new row in this table. Maybe that contains like your user or something, whoever owns your data. And then you can have a super simple authorization method. Let's look at how geospatial data looks like inside a database. So all of your feature layers are just stored directly as individual tables. Your geometry is stored in a hex-encoded string that once decoded will give you something called a well-known text. And a well-known text is going to kind of look something like your coordinates 1, 2, 3, 4, and then point here being that there's no space. There's just a space, there's no comma or anything. Here's 3.14 out of an inability to come up with a different number. there is a library to do this all for you. So this is the part where it is reading the hex string from PostGIS and then converting it into a point geometry object. So it's just stored as a string inside. One of the things that's really annoying about a web feature service is that you don't define endpoints for all of your different resources. You have to define it through like this. The thing that you want is this request equals get feature or request equals describe feature type, right? And so that just ends up with like really ugly route handling. Here, like the post is handled in the same endpoint. You just like if request equals this, do the thing if it's describe feature. Like imagine if you just had like a separate handler for all of this, wouldn't that be so much easier? But yeah, no, the OGC standard is very unwieldy because it is XML. And I'm very glad that we have moved on from that phase of open development. Okay, so the last thing I want to talk about is just how really, really cool the tiny OWS repo is. Because see a real life example of a linked list out in the wild. So all of your layer data is being stored inside of a linked list. And because you have to parse the configuration file, they're using Flex. I don't know, man. If you've taken programming language translations, you know what Flex is. So it's like not only do you see a little bit of PLT in here, you also get real live linked lists. I only thought those existed on LeetCode. Well, yeah, this code base is super simple, and what I'm trying to get at is, now that I spent some time in Go, if I were to do this and do it differently, I would have just taken this. I would have just like used TinyOS for like the vast majority of everything else, because it already does the transactions, it does the querying, the GET requests, and all you need to do is to figure out where it's doing your parsing, where it's reading in an XML file. And then instead of reading a file, you read it from a database. I did find where it is, but now, now I've done the talk, I can't remember where it is. But yeah, I think C code is pretty great, despite all the segmentation holes. That is like, I have like 3 minutes past time, but yeah. Thank you for coming along for the presentation.
Cool. Kevin?
Questions, comments, concerns, complaints? Yeah.
Is there a particular reason you want to use Go instead of another language for geospatial?
Is there a particular language that we can go?
For geospatial, I think Go is great for like networking and for high throughput apps that don't require data integrity.
Is there a particular reason to use Go for geospatial?
Yeah.
I would not. I would say not really.
Okay.
This is one of those. This is one of the situations where there's a lot more mature ecosystems just built around different languages. Like it's not that you can't, right? Like that I implemented all the stuff that I did in like 1,000 lines of code, and Go would just be like a very like easy language to use, right? But is there like a specific reason to do it in Go versus something like Python? With the Python system is just way more mature. Everybody uses it, and the computationally heavy part is already written in C and C++. Right? So if there's like doing in Go is like objectively better than doing a different language, maybe not, right?
Well, you wouldn't want to do it in Fortran.
That's true. There are like worse languages to do it in, and there's nothing wrong with doing it in Go, and you can get a lot of stuff done in Go. And I think really it's not necessarily about the language specifically. It's just that surrounding ecosystem is just built around different languages. Geospatial is old, right? Like we've been making maps for hundreds of years. And then the moment computers came about, we found ways of doing geospatial stuff with computers. So the C ecosystem is old like that. Python is also old like that. But Go is just new. And so you're trying to match like a really new language to something that's just existed for a long time. And really, it's because tiny OWS exists. So it's just like, if this guy exists.
How many lines of code is Tiny AWS?
Huh?
How many lines of code is this project, It's not super important. Don't worry too much about it. 17 years ago, though. That's wild. For that last file bar.
Wow.
That's crazy.
Yeah. There's nothing that new about JS these days for dealing with vector data. All the systems which are tested. That's why part of what I was trying to say is don't write your own. This is a great exercise for learning Go. I learned how to, your HTTP handlers, all the logging, all the kind of, conventions, capital case, everything for public stuff. Didn't really matter because everything was in the same namespace. But yeah, no, I tried to snake case everything at first.
Did you, for your Go server, you talked a lot about write functionality, but you didn't talk about some of the advanced like query capabilities that the WFS protocol allows. Since you have like many different layers, did you have to configure each of the fields? Or is that something you would have to do after the fact? So like if you have an ID field and you want to find all the IDs that are greater than 13.
I did not implement that.
Okay, so that's enough. I mean, I guess that would be like another reason why you would go with geo servers.
Yes.
Right? Because that's already baked in and built in. Yeah, I think one of the best parts of WFS, and something you kind of maybe glossed over, was when you're zooming into like specific areas, you're only returning those particular features. So if you've got terabytes of data, you're only returning what the user needs.
Yes, that was one of those features where if I had more time, I would have liked to implement, but time constraints. Yeah. No, but I get what you mean, like the querying stuff by bounding box, because that does come in here, and you do see it.
Yeah. I tried to implement something with Coop.js, which is a project by Esri, which basically does the exact same thing except in JavaScript, and it's horrible. Because it's in JavaScript. But yeah, this is nice.
Thanks. This language, they said Go is an easy language to learn.
Very tiny language, that's for sure.
So it's a very, okay.
Yeah, just put everything in the main package.
Right.
It'll be fine.
That reminds me of how C++ has.
Oh no, useless use the cat. Don't do that.
What? What's wrong with the cat?
You don't need it. WC-L star test.
That's true, but I'm thinking cat always files pipe into WC.
Right, but that's two processes.
I've never used it.
I don't care. My compute cycles are free, suboptimal.
Yeah. Oh.
So there's like 1,200 lines of testing code, which clearly was not enough because of that apostrophe error. And there is 2,400 lines of not testing code.
Right. This is WSL, isn't it?
Yeah.
What is it Ubuntu?
Huh?
Is it Ubuntu? Is it like app? Do you mind running an apt-get You can actually get lines of code with clock. So sudo apt-get clone, sudo apt-get install clock, and then clock dot
apt-get
clock. It's a CLOC.
Do an update first.
This is a fun tool. If you don't know it, you should.
Is Gorham not automatically sanitize SQL?
It will for you,
Okay.
but because Gorm doesn't know which columns are in the table.
Okay. Okay.
Right, the user can define which columns are in their service layer.
Okay. I was wondering because of the error that you came across.
Apt-get install, what was it called?
It's clock CLOC, as in count lines of code.
Count lines of code.
Yep. And then you can just run clock space dot. Just count lines of code in this directory.
And then
CLOC space dot. That'll actually give you the exact lines of code because it counts things like significant lines of code, for example, like comments don't get counted. I think you ran it against everything.
well, there we go. We have C.
And it didn't find the Go. Interesting.
Oh no, I went back to a different grade.
Oh, you're in tiny
Yeah.
Ah, I see. Here you go. Yeah.
So will that answer?
Oh, yeah. There you go. Cool. Fun.
Yay.
Awesome.
2001 code. How long did it take you to write it?
It took I think hour-wise, maybe 20 to 30 hours spread over.
Did you use AI?
Um,
Huh?
for once I got comfortable with the specific functionality of Go, then yes.
What
Well,
AI did you use?
I think I was just like the biggest functionality that I just like implemented straight off here. Do this thing was give me a script to generate the JWTs and give me the script to parse the JWTs.
You know, you should have said it was going to do your SQL validation.
Oh, I should have done that. But mapping, what's it called? Mapping, where's my example here? Writing these definitions, I all did by myself because I thought that learning how to do the marshalling and unmarshalling and defining the fields is kind of important to just learn.
I'm curious if I see Go on the right side of your screen here. Are you running a like a Go plugin or something?
Huh?
There's a tool in Go called GoFMT. It's kind of like I know that Rust has something like this as well, and generally most editors will just automatically use it. I'm noticing there's a number of places here where it doesn't look like it was run, and I just think that's really interesting.
No, I had to install the language server.
Okay, interesting.
You mentioned you were you wrote a function to change the database geometry to a string. Is there not a function to do that in SQL, or was there a reason why you did it in Go?
Can you ask a question?
So in the database,
Uh-huh.
you have a geometry that is represented by a hex or a hex code, and you're deserializing it, you're unmarshalling it.
Yep.
I'm just curious, could you have done that on the database side?
Like storing it and not as not a hex string.
Yeah, so you can run like SQL queries with PostGIS to turn that into a string or a geometry. You can return it as GeoJSON. You can return it. There's a lot of functionality about like conversion on the database side.
Oh, I just didn't know that feature.
Yeah. That's a big feature of PostGIS.
Oh, I thought okay.
So I think on some end you'd have to do it as UDF. What are you gonna dimensions, you would have to write it as your own SQL function, not built into the SQL standard.
It's important.
Oh, okay, well, yeah.
All right, awesome.
Thank you for coming to my TED Talk.